Thank you for tuning in to the Tampa Bay Estuary Program Seagrass Transect Training Protocol video. The purpose of this exercise is to teach our partners and other interested parties about seagrass monitoring methods that have been used in Tampa Bay since the 1990s. In this training, we will review, number 1, what to bring and how to prepare for your field work, 2, how to identify common seagrass species found in Tampa Bay and assess their relative health and abundance, and 3, where and when to conduct different types of assessments at various locations along fixed transects. In companion videos, we will also demonstrate how to submit data collected in the field using an online web portal and describe how the Tampa Bay Estuary Program uses this valuable information collected by our local partners to inform the management of Tampa Bay. This training is intended to help ensure that the data collected by multiple partners is comparable and can be used to compare seagrass areas both within Tampa Bay and across the 2 decades of monitoring. Before you head out into the field, you'll need to familiarize or refamiliarize yourself with the transects you will be visiting. Look at the last couple of years' worth of transect data, recent SwiftMud maps of the area, and the transect description in the Training and Field Manual Appendix to learn more about what has happened to the transect and seagrass beds you will be visiting. You can learn about previous transect data on the Seagrass Monitoring webpage, and SwiftMud seagrass data is also available online. Depending on whether you'll be visiting the transects by land or boat, you will need to plan for tides as well, using the NOAA Tide Prediction website or another robust tide product. As with any field work, preparation and planning before the workday is extremely important. There is a fairly extensive list of equipment to bring to ensure that the day goes as smoothly as possible. This includes items such as data sheets, clipboards, phone or tablet or GPS unit, measuring tape, meter square and small quadrats, rulers, mask, weight belt, and Secchi disc. A suggested list is available online or upon request. Make sure that electronics are charged and in working order, as well as waterproof to the greatest extent possible. I definitely learned this the hard way. Also, please note that this list and discussion doesn't include any boat preparation that your organization requires. Five species of seagrass regularly occur in Tampa Bay, and you'll need to be able to identify which of these species are present at the sites you are monitoring. Shoalgrass, Haliduli wrightii, is the most common species in the Tampa Bay region. It has narrow, thin, and flat leaves that can grow to about 30 centimeters or 1 foot. The leaves grow from nodes on the rhizomes and have notched blade tips. This helps differentiate Haliduli and Rupia. Turtlegrass, Thalassia testudinum, is dominant in lower Tampa Bay and common in old Tampa Bay and middle Tampa Bay. Its flat leaves are the widest of any found in Tampa Bay and can grow to a length of more than 50 centimeters, nearly 2 feet. Manatee grass, Syringodium filiforme, is found in all subregions except Hillsborough Bay, and its leaves are cylindrical and can grow to over 60 centimeters in length, about 2 feet. If you're a pasta person, maybe you can relate to this analogy. Haliduli is fine like angel hair, Syringodium is round like bucatini or spaghetti, and Thalassia is wide and flat like fettuccine or pappardelle. Widgeon grass, Rupia marittima, is fairly rare in Tampa Bay and looks similar to Haliduli, except that the leaves are alternate and grow from branching points along the main stem. When flowering, very long and leggy branching is present. Pointed tips on the leaves also help to distinguish this species from Haliduli. Stargrass, Halophila engelmannii, is also rarely seen in Tampa Bay, but is fairly easy to identify. As the name suggests, a group of up to 8 short leaves grow from a central base and looks like a little star. The leaves are generally less than 3 centimeters, about 1 inch long. There are also several types of attached and drift algae that regularly occur in the seagrass beds, such as Caulerpa, a highly variable drift algae, and ulva or sea lettuce. Record these separately when they are observed. We use the Braun-Blanquet scale to describe canopy coverage for seagrasses, drift algae, and attached algae. The lower components of the scale include none, which as the name suggests, is used when there is no seagrass in the quadrat. If you see a single blade of a species, it is described as solitary, also called 0.1. One way to visualize the higher categories is to try and mentally gather all of the seagrass of one species together in the square and think about how much space is occupied relative to empty space. If more than one blade but less than 1% of the quadrat is covered, still a very small amount, the term used is few or 0.5. If 1 to 5% of the quadrat has seagrass, the coverage is called 1. When 5 to 25% of the quadrat is covered, it is called 2. Where the coverage is between 25 and 50%, the coverage is called 3. If coverage is observed to be between 50 and 75%, it is called 4. And when coverage is greater than 75%, it is called 5. If there is an additional species of interest observed outside the quadrat that wouldn't otherwise be counted, use the designation 6. In addition to documenting the species present and their abundance in a quadrat, you'll need to describe the condition of the seagrass using clues such as color, damage, or decay. Appearance of seagrass is subjectively rated on a scale of 1 to 4. 1, with a rating of excellent, indicates healthy-looking blades, appropriate green coloration, and none to little blade damage. At the other end of the spectrum, a 4 would indicate unhealthy discoloration, yellow or brown, of the blades and highly damaged leaves. Epiphyte density also uses a subjective assessment of what is growing on the seagrass leaves. Completely clean leaves, without any observed epiphytes, are scored as 1. If less than about 1/3 of the leaf blade has epiphytes, the condition is described as 2 or light. A moderate epiphyte load, a score of 3, will have from 1/3 to 2/3 of the leaves covered. A heavy load is described as being greater than 2/3 of the leaves covered with some type of epiphyte. If you are able to identify the different epiphyte species, please do so. Information on epiphyte identification is available on request. For example, Corophorum, which exists mostly around Feather Sound, looks like little black tubes on seagrass blades, and Spirorbis, a polychaete worm, looks like small coiled tubes, similar to a nautilus shell. At each 100-meter mark, 100, 200 meters, and so on, you will also measure blade lengths and shoot density. The blade length is measured from where the shoot emerges from the sediment to the tip of the seagrass leaf blade. If possible, use completely intact blades, not ones that have been somehow shortened from their full length. For each seagrass species observed in the quadrat, you will pick 5 random seagrass blades from within the quadrat or as close as possible to measure. You will use a small quadrat to assess short shoot density 3 times for each seagrass species at each 100-meter mark. If there is a relatively high density of seagrass, use the smaller 10 centimeter by 10 centimeter quadrat. If the seagrass density is relatively low, use the larger 25 by 25 centimeter quadrat for this effort. Drop the small quadrat into a nearby area or within the 1 meter square quadrat with the same species and relative densities observed within the 1 meter square. Count the number of stems coming out of the sediment, not individual leaves, within the smaller quadrat. Repeat this 2 more times for a total of 3 counts and do not overlap the counted areas. Don't forget to indicate in the web form, on your data sheet, or in your Trimble which quadrat size you used for each species. In addition to your observations of the seagrass itself, you will also need to record information related to sediment type. We classify 5 different types of sediments during the seagrass survey. A classification of oyster is used when the substrate is predominantly oyster shell, and not if you only see a few oysters in the quadrat. Sand is usually grainier particles and feels relatively coarse in the hand. Think about sand from the beach. On the other hand, mud is very fine-grained and feels fairly slimy and therefore muddy to the touch. Muddy sand is, of course, somewhere between the two extremes. And shelly sand is granular with small shells scattered throughout. If you need to clarify your classification of sediment, please put notes into the comments section. Time and depth are also recorded at each 25-meter quadrat location. Depth is measured from the sediment to the top of the water. If waves are present, use your best judgment regarding an average location to measure the water-air interface. You can use either the ruler if relatively shallow, or the 1-meter quadrat in combination with the ruler to estimate the depth at each location along the transect. Finally, the Secchi disc measurement is only done once at the 2-meter contour nearest your seagrass bed, or the deepest edge if your seagrasses go beyond a depth of 2 meters. It is best conducted from a boat, kayak, or canoe. Ensure that the disc is tied to the rope, and sitting or standing above it, slowly feed the line with the disc down into the water until it almost disappears, but you can still see it. Record the depth as indicated on the feeder line. If your Secchi disc is on the bottom and you can still see it, go out to a depth that exceeds the visibility of the disc and measure there. Now that you understand what to measure, let's review where each of these assessments should be conducted along a transect. First, you must locate the beginning of the transect. Makes sense. Using knowledge provided by people who have done this transect, the GPS coordinates, GIS maps, and the description in the training manual, which is available online, or by request, find the nearshore PVC-covered pipe that indicates the beginning of the transect. Then, determine the direction of the transect using similar information, and try to find the other PVC poles for proper alignment. Remember that each transect runs roughly perpendicular to the shoreline. The point nearest land is always counted as 0. If you are starting at the deep edge, possibly because of tide considerations, you must know the entire length of your transect, start at that number, and record the transect numbers counting down. If you are doing one of the transects that has 2 deep edges, consult prior data to determine which is the 0 end. Any deviation from this protocol must be clearly recorded in the comments section. Don't forget to record ancillary data, including transect number, date, names of all team members, name of the counting tech, weather conditions, the deep edge, and Secchi depth. All of the seagrass metrics that are described are collected for each species. If you are recording your data on paper, each species should get its own line, repeating other information, such as time, depth, and small quadrat size for each line. And of course, please try to write legibly. Be mindful of comments you provide, understanding that they may be needed for reference several years in the future. Clarity is important in this and all cases. Starting at the 0 quadrat point and at every 25-meter increment, do most of the assessments, including species identification, abundance, appearance, epiphyte density and type if known, sediment, depth, and time, but not shoot density count or blade length measurements. Note, If you are in Lower Tampa Bay or Boga Bay, you only need to do a quadrat placement every 50 meters, but 25 is preferred and has been the standard for the past several years. Provide a record for each 25-meter placement, including if there is no seagrass in the quadrat. For empty quadrats, please include depth and sediment data. If you see something of interest as you are traversing the transect, please note it on a new line using the Braun-Blanquet number 6 and creating a new line for that data, including simply the species. As clarification, for example, you could also record a comment, such as whether this is the start or the end of this species within the seagrass bed. At each 100-meter mark, 100 meters, 200 meters, and so on, also do the short shoot density count, 3 for each species, using the small quadrat, and blade length measurements, 5 for each species. When you get to the last 100 meters of the transect, starting at a round number such as 400 or 500, the regular assessments should be conducted every 10 meters, but also include the 25 and 75 meter assessments. Please conduct at least a general survey beyond the end of the seagrass bed to complete the characterization of the area. Also, if the entire transect is less than 100 meters in length, meter square placements are to be done every 10 meters, and short shoot density and blade length measurements are taken at both seagrass bed ends as well as the middle of the bed. Congratulations! Now you are ready to monitor your own transect. Official seagrass monitoring season runs from approximately September to November, after the annual seagrass training is completed and analyzed in the summer. We monitor during those months to describe seagrass in Tampa Bay during peak growth. Thanks for your help and attention.